When you drop an object, it's actually quite hard to tell if it falls at a constant speed or picks up speed as it drops. Even in slow motion, it's pretty hard to tell.
But Galileo realized this. First, drop an object a very short distance. It lands with very little impact. But of course, drop it from higher up. This time, the ball easily breaks the tile, which means it must have accelerated, gaining in speed and momentum as it dropped. Galileo had identified something fundamental to all falling objects. They accelerate. He realized there might be a way to measure how much falling objects gain in speed. What he devised was the first ever attempt to measure gravity itself.
He built a long wooden ramp, rather like this, that he had sloping at a shallow angle. The idea was to roll balls down the ramp and measure their acceleration. The crucial thing is that the ramp had to be at this shallow angle to reduce the effects of wind resistance. It also meant that the balls would roll down slowly enough to give him time to measure their speed. But the big problem was this: how do you measure time accurately in an age when there were no accurate timepieces, let alone stopwatches? Well, Galileo came up with an ingenious idea involving the flow of water, essentially measuring time from the amount of water collected in a cup. So we're going to try and repeat Galileo's experiment. I say we because I have a couple of willing volunteers, Gavin and Joanna. 3, 2, 1, go. And stop. Okay, there's one. Now, if you come down a quarter of the way down the ramp, go. Stop. Okay, so now half of the way down, go. Stop. Oh, just in time. Okay, and then 3/4 of the way down, go. And stop. Right, turn the tap off. Okay, so we have our 4 measurements, and I can see a progression from fuller to emptier. But what we need to do now is find the mathematical pattern by weighing carefully the water in each glass. Weighing the water should give us an idea of how long each roll took. And in our experiment, these were the results. Now, there's one immediate thing you can tell. The ball really sped up the longer it rolled. In fact, our results seem to show that the time it took to cover the first quarter of the ramp was about the same time it took to cover the next 3/4. Right. So we have a strong hint of a mathematical pattern. Now we'll see if we're right by placing bells along the ramp at intervals which are based on the results. Okay. This arrangement looks a bit strange because the gap between the first 2 bells is much shorter than the gap between the 3rd and 4th bells. But that's okay, because if we've got our calculations right, the ball starts off slowly, so it covers a shorter distance, and as it picks up pace, it'll cover longer and longer distances. So we should hear the bells ringing at equal intervals in time. Go. Beautiful. So, what does this all mean? What's the mathematical formula? Well, this is something that Galileo worked out. Let's say, from the start, the ball covers a distance of 1 meter in the first second. After 2 seconds, it'll have covered 4 meters. After 3 seconds, 9 meters. After 4 seconds, 16 meters, and so on. If you recognize this progression, you'll see that distance goes like the square of time.
Galileo had found the rate at which gravity speeds up objects. And he'd found another fundamental principle. You can measure the strength of gravity by how much it causes falling objects to accelerate.